related to the gravitational field and the Newton's law of gravitation. Europa is a moon of a Jupiter and contain abundant supply of water, is therefore seen as a possible place for primitive life. Calculate the value of G, the gravity, at the strength, gravitational field strength at the surface. The mass of is given and the radius is also given. So, look, what's a formula to calculate the gravity of any planet or at a specific distance? Because the idea is that, like, if there was an object here, it will pull the object, so that's equal to weight. And that weight is equals to the gravitational force. So gravitational force, we don't have to do this derivation, just I'm deriving the formula. The gravitational force is equals to weight. The gravitational force, according to the Newton law of gravitation, that is the mass of the like planet, mass of an object divided by radius square, the distance between their center, and W is equals to mg. So m will cancel with m. So G, the strength of a gravity, is capital G, mass of the planet, and r square. So we just have to use this formula that the value of a gravity is equals to the gravitational field strength, mass of that object, stellar object, and r square. The value of the G is, this is a constant you will have in the exam. So 6.67 into 10 to the power minus 11 times the mass, which is given 4.8 into 10 to the power 22, divided by 1.6 into 10 to the power 6, and then square. Because this is given in kilometer, we convert into meter by multiplying with 1000, that's become 1.6, 8.6, and then we square. So that is a strength of a gravity, or the value of the gravity, which is only 1.25 Newton per kilogram. It's even less than the gravitational field strength of the moon. Y is maintained in a circular path about a Jupiter. So what happened? There's a gravitational force acting, and that gravitational force is acting toward the center. Like if this is a Jupiter, and this one is representing a moon of the Jupiter, then this gravitational force is toward the center, and that causes its motion to be circular. So refer gravitational force is there from on Europa from the Jupiter, which is toward the center, that cause a centripetal force or a circular motion. Calculate the time taken for to orbit one, and mass of a Jupiter is there, and a radius of orbit is also given in kilometer. So this is radius of a orbit is there. Measure from center of mass from one to another. So what we can here, the centripetal force is equals to gravitational force. So centripetal force equals to gravitational force. The mass of the Jupiter, example mj, mass of Europa as example me, or m1 and m2 I'll use. So say m1 this one and m2, and distance between them is r. So centripetal force is equals to mv square over r, like mass of that object m2, or mr omega square you can also use. So mr omega square we use, and the gravitational force is g, mass of first object, mass of second, and this radius. So these two will cancel out, like m2 cancel out with m2. So r omega square is equals to g m1, the mass of the Jupiter, over r. And this r is there, multiple divided in numerator, so it become r cube, because r square was there. If I remove this, so it become r cube. So this will give a, or if I need omega, why I'm finding omega? Because omega is equals to, we need the time period. So omega is equals to 2 pi f, or omega is equals to 2 pi divided by t. So if I need time period is 2 pi divided by omega. So first we work out the value for omega, g, the mass of a Jupiter, and the radius. We have all of them, we get the omega. After getting omega, 2 pi divided by omega, we'll get the time period of this satellite or the moon. The average distance of a Jupiter from the sun is 5.2 times the average distance from the Earth to sun. Calculate the ratio of the radiation flux of the sun as seen from the Earth to the brightness as seen from Jupiter. So the formula for the flux is equals to power or luminosity divided by 4 pi d square. That's a formula which relate the power and the distance. So average distance between the Jupiter from the sun is 5.2 times the average distance from Earth to sun. So like we have like Earth is there and the Jupiter is there. This is 5.2 times the distance. So because the sun is providing that power, so luminosity will be same. So we can say F into 4 pi d is equals to L, the luminosity of a sun. So first we'll find like the flux on the Earth will be equal to F1 4 pi and the distance is example d1 is equals to L. And the flux on the Jupiter will be equal to F2 4 pi and d2. And this one is square because it follows the inverse square law. So flux is luminosity divided by 4 pi d square, like distance square. So both are receiving the energy from a sun. So luminosity of a sun is same. When we compare the two equations, when I compare these two equations, so F1 4 pi d1 square equals to F2 4 pi. 4 pi will cancel with 4 pi. So I can say F1 into d1 square is equals to F2 into d2 square. Or if you want a ratio, the flux on Earth divided by flux on the Jupiter is equals to d2 square divided by d1 square. And the distance is 5.2 times, like if this distance is x, this will be 5.2x. So if d2 is 5.2x square and d1 is x only. So x will actually cancel with x, so it will be 5.2 square. And so the ratio of the flux on Earth to a Jupiter will be about 6.9, like 5.2 square, 5.2, which is 27.04. So 27.04 will be the ratio of the flux. Is it clear?